We introduced the first framework for human pose refinement, named PS-Mamba. Spatial-Temporal Graph Mamba for pose sequence refinement, which combines spatial-temporal graph learning with state space modeling, SSM, for refining human pose sequence. Given a human pose sequence, we aim to refine them to achieve smooth and accurate sequence. Compare with SOTAs, we have significant improvements in PAMPJPE and MPJPE on AIST++. We achieve lowest acceleration error on human 3.6 m. We present the PS-Mamba framework. The input pose sequence is processed by an encoder to extract high-dimensional features, which are then passed through ST-GSS blocks. Each block includes a ST graph and a ST-SSM with residual skip connections. The ST graph captures spatial relationships using a GCN and a TCN, and dynamic graph weight matrix. These features are processed through spatial temporal scanning and merged with the ST-SSM, followed by layer normalization, a linear layer, and a feed-forward network, FFN. Finally, the refined pose sequences are output by the decoder. Traditional ST scanning, spatial temporal scanning, involves redundant tokens, failing to capture the dependencies between joints. Our GST scanning, graph-guided spatial temporal scanning, under the guidance of the human joint relationship graph, effectively captures joint dependencies while preserving temporal coherence. PS-Mamba outperforms state-of-the-art methods in 2D, 3D, and SMPL representations, excelling in pose accuracy and temporal smoothness. PS-Mamba demonstrates remarkable robustness and performance across a wide range of noise types and levels, outperforming state-of-the-art methods in both accuracy and smoothness. These results confirm its potential for effective denoising in 3D human motion analysis under diverse conditions. PS-Mamba outperforms existing video-based methods by consistently delivering superior accuracy in human pose refinement, demonstrating its effectiveness in capturing spatial temporal features and utilizing state space modeling. Both PS-Mamba and PS-Mamba T provide superior performance compared to SmoothNet and SynSP, offering an optimal balance of accuracy and efficiency for practical scenarios. The ablation studies demonstrate the significant contributions of each model component to improving pose refinement accuracy, temporal consistency, and robustness. The results highlight the crucial role of the ST-GSS block, along with the ST-SSM, ST-graph, weight matrix, and temporal strategy in achieving high performance. Increasing the window size generally enhances model performance, particularly in terms of temporal consistency and smoothness, with WinSize 40 offering the optimal balance between accuracy and computational efficiency. Qualitative comparisons on AIST++. Our PS-Mamba achieves accurate 3D mesh and outperforms SynSP and SmoothNet. We compare our method to FCN on the human 3.6 m dataset. When faced with complex poses or heavy occlusions, both our method and the compared method fail to achieve the accurate human pose. There is an analysis of XL and MPJPE. SmoothMamba achieves both smoothness and accurate pose estimation. Demo videos, our PS-Mamba outperforms other method in mesh accuracy on AIST++. Our PS-Mamba is the first to incorporate spatial-temporal graph learning with Mamba for the task of human pose sequence refinement. We design an effective ST-GSS block that captures spatial-temporal relationships across frames. We introduce a dynamic graph weight matrix that learns the relative influence of edges. Experiments show that PS-Mamba outperforms current SOTAs. Thanks for your time.